I'm a civil engineer by education and an M&E engineer by profession, and I'm working for this startup, which came a bit out of the blue, but the thing that keeps me there, really, because it's a bit crazy, is that it's the closest I've come as an engineer to test some of these hypotheses about repair that I'll talk about today. On the side of that, though, I'm setting up, because I can't actually tell you much about it, it's all top secret. So on the side, I'm trying to work with a couple of former colleagues. Some of you might know these guys, Robert Soden and David Lalmont, who are both heavily involved in the World Bank's group that does a lot of assessments after disasters. And what we're trying to do is set up a cooperative where we look at what we call critical technical practice, among other things, which is that term critical technical practice came from actually computer science and artificial intelligence, and it's trying to get engineers to think reflectively about their role in making technology and the consequences of it being deployed and rolled out. So, but it's the practice bit of critical technical practice that I want to talk about today. So before I get to the critical piece, I wanted to say that I've always thought of us, people who train to be engineers, I know you're not all engineers, but people who've trained to be engineers as essentially non-evil individuals. In our motivations, I mean, I don't mean there's someone in the wing in my engineering office. I mean, just in what we're trying to do in the world. But I'm coming around to this, after questioning all these repair decisions, I now think that being a non-evil individual is necessary but insufficient for doing no harm. And it's that issue that I really am going to get into today. And I only started to think about this after working for not-for-profit international organisations in Haiti. And whenever you say, I used to work in aid, it crops up in conversations. People already assume that if you did aid work, you did something good and brave and voluntary. In reality, it was none of those things. And I honestly felt like I'd participated in something quite shameful. And it's tied into this. So I came away from that experience and I was convinced that bad decisions had been made. And I mean bad in the process of making decisions and in the decisions themselves, which I thought were expensive, potentially damaging, and arguably quite self-serving. And I started to think about these decisions as taking place, because I'd been there, part of the decision making, I started to think about these decisions as taking place in what I call a space between accident and conspiracy. We worked with intention, so we couldn't say it was an accident, what happened, but we weren't deliberately trying to ride roughshod over people either. So that's what we'll explore. And really, I think my interest in why we neglected repair is at the heart of that dilemma, that space between accident and conspiracy. Because when you look back at about 40 years of academic literature and the observers of the humanitarian sector, what they've been saying is we've focused too much on the shelter product and not enough on people's own processes of seeking shelter. We did that. We have a tendency to favour imported boxes, and we neglect local practices of building and the repair of private dwellings. And I'm emphasising private dwellings because it is a particular class of building. It's not hospital, it's not infrastructure. But I felt like in the context of an industrialised aid response, arriving in Port-au-Prince, all of these things played out again. And what's more, I felt that they were exacerbated by engineers giving advice at the highest levels that was structurally sound but culturally inappropriate. And I'm going to talk about some of the underlying things that were influencing that space between accident and conspiracy, including the things that we take pride in operating in a rational, systematic, process-oriented and professional way. So some of you might, well, actually not too many, which is good. Some of you might have heard me talk about Port-au-Prince before, the capital of Haiti. And I have to touch on it because the specifics are so formative and extreme for me. But I actually want to open this out into a much broader discussion. So I'll start with my favourite questions about why money bypasses repair. I want to sketch out some concepts just to bring us all to the same starting point. in the way that, say aid agencies think about this. And then I want to look at some stories from different settings before I bring us back to some contemporary engineering narratives that I'm coming across now in the Internet of Things. So let's start with the money. For me, this is the most interesting and important question. What is it that drives capital to flow to particular places and to certain activities? And what can my tribe, which is engineers, do about this? And from this question, there are loads more. What does this mean for the way humans of engineering make cities? What does it mean for the way people respond to and recover from disasters? How are professional engineers implicated in these decisions? And of great concern to all of us, I think, should be the question, how will technologies of now fossilize or radicalize these flows of money? So why was I so crazed about this question of repair? Well, I went back to Haiti in the middle of 2012. I'd been back and forth a lot from the moment that the earthquake in 2010 happened. And when I went back in 2012, I was evaluating a number of shelter projects that had all been funded by the same donor. And that donor had pledged $500 million in total, which, to give you an idea of just how much money that is, it's about 25% of what Haiti's national budget was in 2009, from what I can dig out. Of that 500 million, about 200 million had been allocated to the housing sector. At a national level, there was a national assessment where the recommendation was that about 30% of whatever went to housing should go to repair of housing. But by the middle of 2012, it was much more like 90% of that agency's 200 million that was being spent only on shelter kits. That they're timber frame structures, they've got a design on paper, they're based on imported materials. Haiti's pretty much denuded of its own timber sources. And there were different procurement and assembly chains for those kits. So sometimes they were delivered as stacks of timber, sometimes they were partially pre-assembled. Didn't really matter. What's important is that the unit costs of those shelters varied from about, for this donor, varied from about $3,400 each to $6,300 each, without overheads. UN Habitat at that time, in 2010, had estimated that just building a house from scratch in the typical style of the city was about $3,500. Those are masonry, and that's a masonry structure. And typically, a household income for people who are the poorest people in slums, a household annual income would be about $2,500. Maybe if you're a wealthier person still in slum areas, that might be $12,000 a year. And the overheads, so on top of that, those costs, the overheads were between 15% reasonable to 50%. And what's more, it bore absolutely no relation to economies of scale at all, or to the quality of the building, of the kind of assembly of these things. What did make a difference was that field-based construction supervision did make a difference to the quality of how these things were put together. But what that should make us ask is, you know, if you've designed something that's highly dependent on lots of construction supervision, is that a good design? Which are the factors actually in that supply chain, in that procurement, that are giving rise or making a difference to the riskiness of a house? Because it might not be the things you think. And if timber's already scarce, and as is the case, timber had been banned from the city since the 1920s because of the risk of fire, is it really relevant if you invest loads of money in construction skills to monitor timber construction? Is that going to be valuable later, that investment in those people? Because are you going to keep building in timber? Probably not. I mean, you could also say, fair point, if construction quality is so poor, skills are so poor, if you decided to build anything more complicated than a timber frame structure, you'd be in even more trouble. That's also a plausible argument, but that's completely untested as untested under supervision of aid. Loads of people were doing that anyway without any support or advice. So There isn't really a clear answer to whether it was right or wrong to do that thing. But in the aftermath, and I've just given you a sort of rant about it, in the aftermath, it's almost the only question that gets asked, was it right or wrong to do that? And it gets all this attention but that's only because the kids, they drew so much money and they were the only solution, really. And it was repeatedly documented, repeatedly photographed and debated. But my preoccupation is more that at a strategic level, engineers played a part in this decision. And ultimately, that decision, I don't think, was very process-oriented, it wasn't very systematic, and it wasn't actually very rational. Because it wasn't systematic, because the kits, the physical form of those kits, they're like glorified garden sheds, basically. It's really just a reflection of the domination of technical voices. It's a reflex to control risk on one hand and focus on a single hazard on the other. But I'm totally unconvinced that it controlled risk. Especially when we come on to look at the shelter sector's sort of own algorithm for triage and for minimising risk. It wasn't process-oriented because it didn't really take a systemic view of risk. The kits took to the lion's share of the money to the exclusion of all other options, and it was like a homogenised response to the complex texture of the city. But as I've said, in the end, cost and quality and the pace of that delivery varied so much that it wasn't even homogeneous in the way that it could have any of the advantages of mass production. So it wasn't rational because actually the technical response to the risk of earthquakes, and we're going to go into this a bit more detail, was to impose high safety standards. Okay, so that meant spending money on thousands of these kind of engineered, imported shelters, a little bit of money on a very few newly built houses, which were very slow. And in my view, that was like doing heart surgery for a few people when we need the kind of structural equivalent of soap and water to be rolled out at a much more realistic and impactful and sustainable scale. So what were engineers doing? Well, they were saying things like this. These are all quotes either from genuine people in genuine meetings or from documents that were written at the time. So knock it down, start again. We trained people, they're still doing what they did before. That you will hear everywhere. And strategically dismantle the top floor of houses. If you knew how the city was formed and built, that would not seem like a strategic suggestion, not in a strategic. It's technical, but I didn't think it's strategic at all. Two more quotes. The one on the left is really long, but it's really strong, and I'm going to read it out because I think lots of you will agree with it, and I completely disagree with it. Any organisation that takes on a repair programme and decides it does not need to meet code, whether national or provisional or borrowed from an advanced country, takes on huge risks. That's risks taken by the organisation. Is that important? Puts the beneficiaries at huge risk and sets an incredibly poor example in a place that desperately needs to be inspired by good examples from countries that have their act together. We couldn't do this in London. Why should it be good enough for Port-au-Prince? And the last quote there, genuine quote, very, very painful to hear when this was said at a very stressful meeting within about 4 weeks of the earthquake. But I later came to understand that was one of the man who said that, and who now has an extremely important job, much more important than he had when he was my boss. He was one of the few people speaking the truth about what was going on. Sorry, anyone from NGOs. That sounds so cynical, but not every disaster is like this. Haiti was an industrialized disaster an hour away from Miami. That drove a lot of this. And Haiti is, for 200 years has been fought over for various political reasons. So, those are some of the things we said. And I want to look a little bit at the procedures, the routines that we were using to try and understand what was happening. So I've mentioned that these are some different ways of thinking about this. These symbols actually came from some work I did with CARE and with ARUP on the kind of evidence that was being produced after disasters. So what are the documents we produce as engineers and how accessible are they? Like, what do they contain? Are they really answering the questions that need to be asked? So we're going to look at some of the procedural ways we think about these problems. This will be familiar to some people. This I'm calling the shelter process algorithm. This is one of the, we talk about shelter processes a lot in the shelter sector. This is one of the graphical ways of trying to convey that. There's lots of things assumed in here. It's just an example. It's not always like this, but there's this notion that over time people will upgrade their shelters from something very flimsy and basic. And what this is trying to indicate is what gets prioritized in the navigating all of those post-disaster decisions. This is the repair algorithm. This is what's in the main guidance. It comes from one of the handbooks. It looks really simple. Well, I don't know if it does, a bit messy. I'll tell you what it's trying to say. It's got nice, neat categories. It appears to be optimizing for structural safety, and it leads to a clear set of interventions, and it's discernible, by which I mean it's documented, it's written down. You can interrogate that, which I say is good. And it goes like this. First, you judge whether the location is safe enough. Then you ask if the building is, what state the building's in. If it's beyond repair, rebuild it. If it's not damaged, improve it so that it meets code. If it's damaged, what do you do? So the sort of middle grey zone of damage, well, you've got to estimate the cost of the damage, diagnose the defects that resulted in damage, and then orchestrate repair. And I use the word orchestrate because really the response to repair is a mass customized, seismically sound repair of masonry structures. They're not, not unconfined masonry structures that are privately owned, private assets, but they're often not owner occupied, and they're spread across a massive city. So that's not easy. That's not an easy proposition. If you look at this again, though, I mean, I would ask, are the decisions technical assessments of safety, structural diagnoses, or feasibility assessments so you can triage and prioritize? I think the real optimization buried underneath this is actually whether the cost of starting again is less than the cost of fixing the house, given the seismic risk context. But I'm not sure all the costs are actually in this algorithm. So if my house is damaged, what about the costs and the risks of the meantime? I'm waiting for government to plan something or announce compensation or let me know a timetable for when I might get some help. I'm waiting for an NGO to arrive and, save me. I'm waiting for remittances to arrive from Miami, waiting for builders and labour to be available, etc. What about the costs and risks I face in the meantime of living under canvas? What about the costs of my dream home, which I can now, I could have a chance to realise? And what about the slow, inaccurate engineering that's inevitable given the practical difficulties of this mass bespoke technical diagnosis? It's not easy. And if this wasn't complicated enough, the other algorithm that NGOs are deploying is for beneficiary selection. So this is optimized for targeting resources at the most vulnerable people. So this algorithm goes like this. Is the family displaced, yes or no? If they're displaced, prioritize them. Is the family vulnerable? And that's in terms of the characteristics of that individual family. So is it headed by a single female? Are there children in that family under 5? Are there elders? Are there people who are chronically sick or disabled? So it's like your individual vulnerability properties, are they present in that household? If you have those characteristics, you get prioritized. Annoyingly, and this was not explicitly examined, the most vulnerable people don't necessarily live in the most vulnerable buildings. So if you go through this and target your collapsed buildings, you're not necessarily targeting the most vulnerable households. And in fact, if your dominant technical solution is that shed, it can only ultimately be delivered to a plot of land that's already been cleared of a destroyed building and can only be received by a household with permission to access that land. And urban vulnerability is often characterized by an inability to access land. And when you disaggregate, not many people had a chance to do that. I did, but I wasn't allowed to publish the report. A lot of people who got these sheds were the people who owned land. That, the renters did not. So what would you have done? It's really hard, isn't it? So clearly a good response might arguably be spend money on controllable timber sheds, because then you don't have to engage in this messiness. And for everyone else, you can do what we did, which is slowly produce some disputed technical guidelines for more typical building types. And that's what happened. And that's where the quote in the title of this talk comes from. No, actually, the quote comes from Marie Antoinette. But I was copying an engineer called Ralph Langenbach, who's actually an architect engineer. And his view about the technical guidance that we produce is that efforts to solve the problem only with the dissemination of technical reports for engineers may be best described as a Marie Antoinette approach to earthquake hazard mitigation. Let them eat cake. So what he's saying is if that's what you think you're doing to reduce risk, you're deluded. Oh, that was him. I don't know why all my little cartoon characters are smoking. That's not to encourage you to smoke. A lot of people were smoking in Haiti when they were really anxious about this stuff. But anyway, don't do it. Stories of buildings. So I wanted to think a little bit more about the rationale behind this. So these complexities made me think that the way the money was spent it obviously isn't an accident and it's not a conspiracy. I was there, so I know it wasn't an accident, I know it wasn't a conspiracy, but it was rooted, I think, in our ideas about professionalism. I think it was in something to do with our ways of thinking. For example, we kept on reporting how well we did what we said we'd do, but we never properly questioned whether what we said we'd do was still the best thing, and we didn't really re-examine our early assumptions to see if they still made sense. Like timber structures, if they can get there within 6 months, brilliant. 2.5 years later, still being built, not so cool. So, and also the images, the stories, the maps we made for ourselves, they just kept steering our focus away from people's capabilities and back towards really their victimhood. And I want to look at some different narratives about intervention and these are, well, they should be quite familiar. So people, especially powerless people, are not aware of risks. That's a common trope. People don't learn. I mentioned that already, the common trope. And people don't know how to do a good job, another classic. And people are just irrational, not like us. So some stories of buildings. So this, I've shown this a million times. I took this picture about 10 days after the earthquake. When I went down, it's on the steep side of a ravine in Port-au-Prince. I went down in the morning, took the picture. I came back at night at dusk, and people were turning lights on down at the bottom there, which was that whole hillside's a pretty rough place to live, but the bottom of that hillside is a really rough place to live because when the rainy season comes, it floods, it swells with sewage and solid waste, and if you look closely, you can see that actually the houses at the bottom they've got tin roofs. It's really bad place to live. But they went back. That was the first place they went back to. So why? Well, maybe it's because this hillside is actually an excellent example of risk mitigation because it was a choice of location from a very limited set of choices that minimized the risk of eviction. It minimized the risk of high rent, minimized the risks and costs of finding and getting to work, and it maximized the chance to live closer to acquaintances already in the city. And it was a choice of that's in terms of the place. In terms of the building, those buildings were quite carefully adapted to protect people from hurricanes, from material scarcity, there's no timber, and from noise, and from burglary. So my solution to that kind of diagnosis of this hillside is for all of us to assume, we can still assume people are rational. People are rational. I've told you they're making rational decisions, but in a context that's broader than the one you were thinking of. So we can still assume risks are measurable. We just have to take a broader view of risk. So that's our solution to take away from that story. This is a mosque in Sindh province in Pakistan. It was observed that mosques withstood a lot of the flooding, the flash flooding, and some of the standing water in Pakistan. When we sat down with masons, and the technique, by the way, is like a kind of cob building technique. So you get a handful of mud, you round it, and you bang it on, and you keep going round, and it's quite a skillful job of masonry. When we sat down with the masons, they went through all their improved techniques. So they raised the floor levels inside, they made much deeper foundations, they compacted the earth to give the walls greater stability as well. They sieved the soil before they used it to get the clumps out. They made the walls thicker at the base. They soaked the mud overnight to disperse the clay particles, and they used like wheat chaff and kind of chopped up jute bags in the mud render to reduce shrinkage and cracks on the outside, and they maintained those buildings annually. So and obviously all of those things took more time, right? Which means more money. Yes, partly that was because they were religious buildings, they were mosques. But more important, and so the labourers had an incentive, but more importantly, the dwellings were mainly occupied by landless tenant farmers. And so when they were moved, by custom, it was like customary that if you got evicted and moved on, which was seasonal pretty much, the only bit of your house you could take with you was the roof. So there's twin vulnerabilities there. The walls were rubbish because none of this time was taken over the walls. But the roof was like your bank account. So your assets, you started to invest in that roof. So you would see in these mud huts, steel girders that people had brought from Karachi up into that house because that's the bit they could take with them, and that's where they put their asset up there. So people did know how to do this. The incentives went in place. So we can also, as engineers, take a broader view of building knowledge, accept that non-engineered materials can be made structurally and culturally appropriate, and we can examine incentives. Those are all things within our ways of thinking about rationality in the world that fit. So our next story is about Padang Pariaman. This is in Indonesia. CARE did what was actually really an innovative project where we did very, very, very small cash grants to families who'd been affected by this event. There were, by the way, 115,000 houses that were destroyed by this earthquake in Sumatra and 135,000 that were damaged. We had about £1 million from DFID. And it was quite incredible because every house got a little grant, and then that seeded the reconstruction of their houses. It was all in rural areas. What was really interesting about this place is it's matrilineal. So women own and they inherit land. When you decide to build a new shelter, the new husband that you've just married will move in onto the land of his wife's family. The wife's room, childhood room, becomes the start of the couple's new home, and then they gradually extend it. And the whole thing is financed by, when a baby girl is born, people send jewels and gifts and bracelets. When you build a new room, you liquidate some of those bracelets and you put that money into extending the house. Unfortunately, it's matrilineal pre-Islam, then Islam came, and then colonialism came. And colonialism was like, the man is the head of the household, so all the households are registered in the man's name. And what we did, as we did the handouts of cash, is we did technical training. So a majority of the people who were given technical training were actually female householders. And that was not because it was matrilineal, it's because they were at home, not out doing cash work, and they had time to attend. But they had the least construction experience to get anything out of what was quite a technical training. They had the least power, in spite of this system, to influence the decisions of masons. So even the youngest inexperienced masons, if you were a lay householder, male or female, if you didn't know anything about building, they didn't listen to you. So this and everything we did was in rural areas. Buildings in urban areas completely untouched, no shelter assistance almost. 54% of people, when I did this evaluation of that project, 54% of people affected by that earthquake were still in structurally unsafe houses, not touched, no technical advice, and loads of houses like this with an unreinforced brick gable end, that had just fallen in onto beds and stuff. Nothing touched in that domain. In Haiti as well, by the way, it's the opposite situation where if you were a householder wealthy enough to commission construction of a house, you told that builder what to do. And one of the weird anecdotes I heard was that householders liked to see really thick mortar because they knew that builders would scrimp on cement, and they thought a good sign that a builder hadn't scrimped on the cement was like a nice thick mortar. Of course, the builders still scrimped on cement, so there was a nice thick, extremely brittle and not very helpful mortar in there. So what I don't want you to think is the solution to this is targeting better training. What I want you to imagine the solution to this is there's a lot that you cannot see here about power, about voice, and about how those things intersect in terms of who gets to decide stuff in remaking houses. So this is actually from nothing to do with contemporary shelter, but it's from an archaeological study about shelter in the Caribbean. I want to mention it because we talk about this mantra of shelter being a process, not a product. Shelter can also be a service, and it can be an institution. I won't really mention the Kobe earthquake, but what I want you to think about is our ideas about housing and permanence can sometimes be completely different to ideas about transience, displacement, remaking and changing housing. The guidance in the shelter sector on transition, it wasn't really supposed to be about like there's a period where people transition or a kit that transitions. It was about the processes and the trajectories of people who are seeking shelter after a disaster. But because we keep doing these prefabricated shelter kits, they get called transitional shelters, in our imagination it's become the kit always that's in transition, not people actually. And it reduces it to this technical problem of design. Can it be upgraded? Can it be moved? And there are no further questions asked about people's wishes, right? So if you're displaced as well, and this was true in some evaluation we did in Western Sahara, when you choose a place to settle and invest, a lot of your decisions about where you put money are based on your anticipated return. I mean, that's really hard to respond to with anything technical. I mentioned Kobe because this idea of shelter as a service or accommodation as a service. In Japan, outside major cities, land's super expensive and a house is like a car. You spend money on it and then it depreciates like a car. So land has this permanent quality and houses have an ephemeral quality, and they're seen as kind of transient objects. And in the disaster law in Japan, you can end up with a really, really, really expensive prefabricated house given to you by the government because they have a culture of not giving people handouts, and they would rather give you an in-kind, ready-made $35,000 per temporary house than give you any money, because that is just not a norm, and it's written into law that it would happen like that. So they give you an in-kind house that's a time-limited shelter service, accommodation service after a disaster. So totally different way of thinking about this. So the last little thing I want to think about in this idea of what is a house, what is a home, is that a house is also a kind of institution. It's shaped by us, it's shaping us, it's about our agency, our choices in making houses and the inside of our houses too. It's kind of about adopting and sharing ideas and dreams and technologies as well. And these changes aren't just kind of incremental, object-focused, happening on a single path and ending up with like some kind of stable, permanent thing. It can be historical, it can be inexplicable what people do, or inexplicable by us, cyclical, and the evidence might not be within your grasp to explain the reasoning, okay? So housing kind of constitutes and catalyses other change. That, by the way, is really relevant also to housing in the UK. So the solution here, if we think of housing in this broader way, is to take a relative or contextual view, not just of space. So we have lots of different codes for different places, and we think we're being really good about context and space, but I think we also need to think a little bit more about time and the context in which people view time as well. Because risk is actually, frameworks for risk are a way of governing the future. So the time horizons you think are important matter to what you think about risk. So, riskiness, that's what we're getting onto. This is the Aylesbury estate, which is in Southwark. I was involved in the public inquiry about the compulsory purchase of that estate. And the story about riskiness I just want to touch on is this idea, and we carry it actually, that starting from scratch is less risky. So this might seem like a bit of a left field example, but we got approached while I was at UCL by Just Space and the London Tenants Federation because they felt like a lot of the decisions to demolish social housing in London were being justified on a technical basis, i.e. These older buildings just have higher operating and maintenance costs and we're better off knocking them down, starting again. That's the kind of justification. When you look closely at this question about demolition and whether it's socially, economically, environmentally justified, there's a lot of gaps in evidence. It's often painted as if the evidence is very contradictory or conflicting. Actually, it's just really patchy and context specific, and quite often totally impenetrable, especially in planning. So the main problem with decisions around demolition of this is that the standard of evidence was a bit pathetic. And so if you purchase compulsorily as a local authority, you have to demonstrate that it's in the public interest to purchase that. And the public interest is local, and it's environmental, and it's social, and it's economic. But all of the scenarios that were calculated to work out whether it was in the local public interest are sort of calculated as percentage changes or improvements, compared to this notional baseline, which is a hypothetical new thing which complies with building regulations. So there's no like, what if we didn't knock it down scenario? What's the percentage change there? Like, so this whole process of evaluation and trying to judge the riskiness of this building in terms of letting it stand and repairing it, when it's presented, it makes, there's a lot of numbers, there's lots of percentages, so it looks like it comes from maths, and there's also thousands of pages produced by engineering companies as part of the planning submission with those percentages and numbers in them, and it's really just comparing it to a notional hypothetical thing. It's totally normal in planning, by the way, but it doesn't really help establish any risk. So the solution here is, when we're thinking about questions of viability, because this is really a question of viability, whether you repair, is take a broader view of the evidence. What is produced, who's producing it, and what's missing from that? Because it happens here too. This, you can't tell what this is at all, is notional completely, but I was lucky enough to interview one of the geotechnical engineers in Christchurch, who worked after the Christchurch earthquake. And he's really amazing, and he did a lot of the mapping of liquefaction risk. So they ended up with green zones, amber zones, red zones. And I spoke to him about 2 years later, and he said, in retrospect, he wished they'd classed everything as either red or green, because anyone in amber didn't know what on earth was going to happen for them. So that's that repair space, right? He thought he would be able to go back and find out more and be more accurate and measure risk better, but actually it just resulted in massive delays. People killed themselves when they were in those zones because they didn't know if they could go home, they didn't know if they could rebuild, they didn't get compensation. And he felt really terrible about that. So, and the other weird thing that happened, this is Christchurch, New Zealand. The difficult parts of the city, engineers did not work there on reconstruction of housing because engineers have unlimited liability for residential work. So what he said was, cowboys went there. And so it's not best laid plans. This is a developed economy. It wasn't very straightforward. So what is the solution when you're making these decisions, this triage into different categories? Maybe sometimes it's better to be categorical, green and red, and be a bit wrong right now than try to be bespoke and be late with it. Or maybe it's just better to be realistic about other things that are happening at the same time. I'm not going to talk about Japan. That's Japan, you can't tell. But I do want to talk about thresholds of risk. The reason I put that in is because the modelling for deciding on zoning in Japan was based on some of the most elaborate earthquake and tsunami modelling in the world. And it resulted in building a massive seawall for 500 kilometres of coast. Loads of people depended on the sea for their livelihoods, and they really did not want that wall to be there. The engineering response was, it's based on the best modelling available. If you said, but what about 1 in 100 year return period and 1 in 1,000 year return period, and they said it's based on the modelling, I'm like, those are return periods, they're not based on the modelling, they are inputs into the modelling. It's actually a really hard conversation, but anyway, maybe you know better, maybe there's a better argument about that. That's the Japanese risk thresholds. In the UK, we have risk thresholds that are really clear and set for public health. If a medical intervention can give you 1 extra year of quality life, and it costs £23,000, we'll spend the money on it. If it doesn't, we won't. In health and safety, if you can demonstrate that you could avoid 1 extra death on the railways for less than 1.3 million. You're obliged by the HSE to invest that money. But this is what the chief executive of NICE, that's the National Institute for Clinical Excellence, says about those thresholds. There is no known piece of work, empirical work, which will tell you what that threshold bit should be. So what I want to get across there is this is not a calculation, it's a deliberation, it's political. And I think the solution in the face of knowing that is to recognise it. Finally, on the stories, I mentioned that we often get really het up about thinking we're giving poorer people lower standards of things. I wanted to give you an analogy from the water sector, which is in the 1980s, the UN had what they called the decade of water and sanitation interventions. And the results were so disappointing that it resulted in a massive kind of war in the WHO about whether the strategy of trying to roll out standards for water quality across the world was actually the right objective. And public health people inside the WHO, some of them said we shouldn't give poor people the lower standards. Other people said, you are giving people a system of water quality standards that depends on sampling water, running that water through a laboratory infrastructure, often waiting like 20 hours for the sample to incubate so you can tell if it was contaminated, to guarantee people's health. And that is far more dangerous and risky than taking an approach where you don't set a water quality standard, you roll out a way that communities can assess their water systems themselves for the worst contamination and worst risks. And this resulted in guidelines that were graphical, visual, training for people who ran these networks, not necessarily to measure and monitor the water, but to look at the system and say, where is the contamination coming in? Let's fix that first. And that's what the WHO decided to do. They thought that was a better way of thinking about risk. So that's about thinking about risk in the aggregate and thinking about ethics and values in the aggregate. There is a structural analogue to that, which is the Italian building code that has different criteria for historic buildings that have other value. And they have a different limit state recommended and different interventions that you can make. It's quite interesting. You may know about that, you can mention it at the end. Okay, so people had different explanations for what happened in Haiti. We had hammers, so every problem looked like a nail. I think that's full of insight. We're used to designing complex buildings in simple contexts. We couldn't do simple buildings in complex contexts. Very true. The questions are alive. CARE just published a really interesting report on self-recovery, which acknowledges that understanding what the safety question means is really hard to resolve, and it needs more work and it needs interdisciplinary research. I tried to set up these stories. I'm trying to do this in a slightly meta way, but it might not work. I'm setting these stories up in a way that satisfies me as an engineer. So there's a diagnosis of problem, little story diagnosis, and then a solution. I'm also, because I think some of the things that went wrong are to do with the way we think about the world, I'm trying to also be a bit brutal and unfair in my stereotyping of us as a professional group. So you can challenge me on that. But what the main point is to try and stretch the ways we think. So we take a broader view and we try not to demonize or fetishize or fantasize about people who are in other places, whether that's estates in the UK or villages in Padang, in ways that delude us into thinking we can solve problems somewhere else. So yes, this can help us kind of stretch our thinking about the shelter process algorithm. We can think about how people obtain land. We can imagine that there's a whole cityscape. It's not just a building. And there was a cityscape there before, and why do people choose those technologies, and why were they in those places? We can, and then we can think about that transition process. And we can think also about the ways the imagery, right? I mean, going through documents, every NGO document is full of women and full of children of colour, needless to say. And yes, I totally agree those people are vulnerable, but there are other people that we don't take photographs of, and we don't acknowledge their power, and we kind of don't engage at all. And it's very clear in the documents we're not engaging with those things. The repair algorithm, if you actually try to map out what happens, you cannot draw it anymore. You need a narrative. You can't make... This is actually the process after the Kobe earthquake. It is so complicated, doesn't fit on a diagram, you need to explain it with more than just a diagram. So yes, we can measure more things, so we have more evidence in our rational system. We can build in more interactions between subsystems in our systematic approach. We can ask more questions, have more iterations in our procedures. We can have more humility in our profession. But actually, it's complicated. And I'm going to skip through actually a little bit, the last bit. This question of our role as engineers, we have a code of conduct. NGOs also do. Loads of things in that code of conduct are contradictory. They also contradict some of the objectives that NGOs are trying to achieve. We don't like to think of ourselves as, simple followers of rules, actually. But I think we should ask questions about whether our duty is to design and check for compliance with safety rules that have been set for us, or if there's something else going on, because everyone I try to talk to about this frames this question as a question of high safety standards being their professional and ethical duty. And I think that we should frame this as a professional dilemma about what your role in safety decisions is, and I think we have an ethical duty to confront some of the contradictions. So let's think about that in a little bit more depth. I've really slightly slagged off engineering, but now I'm going to say the things I think are amazing before I finish. So I've had this really luxurious opportunity really to think about how engineers are trained. I've been teaching engineers, so I had this look at how we think, and I can see how my education embedded tendencies to digest the world as systems and patterns, but it left me a bit, happily innocent, to be honest, about power. I wanted heroes and villains. I wanted comic book metamorphosis that was easily measured by before and after photos. But although I can see that I was really naive about the colonialist tendencies of the aid machine, but I also find a lot of the political critiques to be really, really naive about technology, because even though I really hated those glorified garden sheds that we set up in Haiti, that first day when our team witnessed that first shelter go up, it was euphoric. It was so hard to get everything there on that day. It was euphoric. And it was like this kind of phoenix. It was like this compulsion for the ordinary repair of a home, and it held such meaning in the rising after that disaster. And I don't want the written accounts of that to overlook the joy and the commitment and the mistakes that we made and the dignity and the appetite for all these technological fixes. Engineers come with this kind of unencumbered solutionism. We're analytical, we're careful, we're willing to improvise and innovate. When we work together, and I've been really lucky with just amazing people that I've worked with, we bring this humility of collective and anonymous authorship, and I think that's a really special thing. Plus, I don't know if you've noticed the recent press coverage about decolonising the Oxbridge curriculum, but just because you have an elite education that's not in engineering and it's in the humanities, it really doesn't mean you're any more likely to be curious about plurality or the way knowledge is produced. So I love what engineers do, and I think we need to just engage a little bit in these questions. So what I've shown you, I think we can imagine a future maybe where, and I'm seeing this now in the company I'm working for, it's a world of data and craft. So on the one hand, we have this emphasis on gathering loads and loads of data and monitoring loads and loads of things in a way that we never have before, but we have this need to understand what is bespoke, this need to understand the materiality of what's happening, the sights and sounds, the feel, the builders, the users, the place, and those things need to be brought together. I think this is really going to challenge the way engineers regulate and self-regulate, especially when a lot of our solutions are quite regulatory. But imagine if consumer protection and all the safeguards on public health and safety move away from codes and labelling that's devised in ideal conditions and it's backed up by governments, and we shift to real-time monitoring of vibration, strain, displacement. We check system performance in context. That's really going to change a lot of things. So what I've shown you is what are basically some really simple and discernible algorithms. So they're open to scrutiny, they're written down, a lot of them are regulated by government. A lot of new algorithms are none of those things. We should be worried. I'm not arguing against engineering and technology. I'm really arguing against homogeneity in the way we think about these things. So technology is going to change our jobs and the status of what we do. But I'm starting to think, especially in the job I'm doing now, that technology might be the answer to some of the questions that really plagued me after Haiti about our inability to invest and repair. I think instead of the technology discussion being about robots and stalking and riots, maybe we can make ourselves a world which is a bit more about craft, about care, about sensing, enhanced by the engineering of fixing, getting dirty, addressing the bespoke, and steering machine learning with other groups of people able to bring their experiences, qualitative, ethnographic insights to what causes things, not just what appears from a distance to be kind of correlated. And for now, I think as professionals with some power over decisions, if we just spent 5% more time in any meeting, whether it's about cities or infrastructure, machines or algorithms, thinking about who's speaking, who's silent, who's present, who's absent, and trying to shift this, we might rebalance decisions and change who the world's being built to please.